So we've got, the title will be Statistics and Probability. Okay, and we're going to start with chapter 1. Which is called Representation of Data. All right. So statistics and probability, chapter 1, representation of data. So first of all, I just want to do some vocabulary. So let's just define statistics and probability first. So what is statistics? Does anybody have a definition? It's quite a hard one, really. Maybe one you've not thought about before. I would say statistics is a way of collecting, organizing, interpreting, and analyzing data. So collecting, organizing, interpreting, analyzing data. Okay, so that's essentially just taking the data and maybe just putting it in a table, manipulating it. Maybe you take all the numbers and you square them and then do something to them, or graphing it, putting it in a graph or some kind of plot, maybe a histogram or you know, box and whiskers plot, stem and leaf kind of plot. So this is representation of data, taking data and trying to understand that data. And there are different ways that we can show the data or represent the data that will help us to understand different things about the data. Okay, so that is statistics and probability. Should all know probability, not just for completeness. Probability is the chance of an event occurring or happening. So we talk about events. What is an event? So an event might be flipping a coin. That's one event. Or an event might be rolling a dice or picking a card or you know, whatever it is. That's what we call the event. And the event then has a probability or a chance to occur or not occur. Maybe the event is, will it rain tomorrow? And there'll be a probability that it might rain tomorrow. So there'll be a chance of it raining tomorrow. So the event is rain tomorrow, and the probability is essentially just a number, right? So probability attaches a number to an event, and that number will be between 0 and 1. So it could be 0, it could be 1, it could be any value in between those two. If it's 0, it's got no chance of happening. If it's 1, it's got 100% chance to happen. If it's 0.5, it's 50-50. So you've learned this before. Probability. And I guess the other thing with probability is, oops, try and make that neater. We often describe it as the number of like a fraction where the number on top would be the number of ways the event can happen. Divided by the total number of possible, the total number of possibilities. The best way to say it, number of possibilities so let's take a specific example of that. Let's think about rolling an even number on a dice. So if I roll a single die, there are 6 possibilities. How many of those possibilities would match the event of rolling an even number? Well, there are 3 even numbers on a dice. We've got 2, we've got 4, we've got 6. So the number of ways that I could roll an even number on a dice is 3. There are 3 ways I can roll an even number on a dice. The total number of possibilities when I roll a dice is 6. So the probability of rolling an even number on a dice is 3 out of 6, which is equal to a half. Okay, that is the essence of probability right there. That's how I like to think of it anyway. So where are we up to now? What time are we up? Still got a little bit of time. All right. So this chapter, we are going to think probably first and foremost about diagrams. So which diagrams do we need to know? We need to know stem and leaf. Know box and whiskers. Histogram. And cumulative frequency. Graphs. And then after diagrams, we'll move on to analysis and understanding. Analysis. So this will be using graphs, the above diagrams and plots to find things like your mean or median or range or your interquartile range, which I'll call IQ range, or your standard deviation, things like that, right? So this is the analysis and understanding part of topic 1. So we need to know how to construct these diagrams, and then we need to know how to understand those diagrams. Basically, yeah. Okay, so let's think about stem and leaf, and then I think we'll probably be out of time. So this, I mean, I think probably most of you know this already. This is GCSE maths, but it probably has been a while since you've done it. It never hurts to see it again. So we'll start with our first diagram, stem and leaf. Okay, so stem and leaves, they often look like this. They might have this would be the stem, and these would be the leaves. Right. So that would be what a stem and leaf diagram might look like. This right here would be the stem, and these are our leaves. And you will always, with any stem and leaf diagram, get a key. So this would be the key. So 0.02 is the number 2, right? It could be 0.2, or it could be 200 or 2,000 or 2 million. That's why the key is really important. It's not necessarily going to match up. You know, I might want to draw a stem and leaf diagram about something where the difference in values is tiny. So this could be I could be looking at the 3rd decimal point. So this might be like, you know, 0.2 might be 3.0002, and 1.1 might be 3.0011 or 3.0023, right? So I might be looking at some values that are very, very close together, and so my key would need to reflect that. I could say 0.2 is 0. Or maybe it's something like 5.6702, and then 0.4 would be 5.6704, right? So the key is very important. Be careful with it. I'm just going to say it's 0.2 because that's kind of standard. So stem and leaf, but we could also have back-to-back stem and leaves, so we need to know how to draw those. So this is just a typical stem and leaf. Usually the stem goes on the left, leaves on the right. We can have back-to-back stem and leaves. So this is where the stem is in the middle. And you don't always have to start from 0. And I could have some leaves to the right. So that might be 11, 12, 15, 24, 28, 29, 30, 37. I'm just putting these in at random. And maybe there's no 40s on that one. And then on this side, I could have 21, 22, 23, 34, 38, 39, and 45. So again, the key is really, really important here. So if we have a back-to-back stem and leaf, maybe we'd want to specify 2 keys, right? So that might be 12, the number 12. But what if we look at the other side, right? If we read the number the normal way, we would have something like 32. That's not 32. It's actually got to be read back to front. That would have to be 23. Okay. So what would be the purpose of doing this, making these back-to-back ones? Because you have to read them the other way around. Well, it's a comparison. It's comparing 2 sets of data. So these could be, let's say, they look like maybe ages, the ages of some people. Collection of 2 people in 2 different rooms. Maybe this is room A and room B. And these are the ages of the people in that room. So instantly I can just say, well, how many people are in room A? I've got how many leaves? 1, 2, 3, 4, 5, 6, 7, 8 leaves. So that's 8 people in room A. How many in B? 7. I've got 7 in room B. I can then talk about, well, the people in room A appear to be slightly younger than the people in room B. Why? Well, because the median age is less. I could say, well, the range of ages in room A is from 11 to 37. and the range of ages in B is from 21 to 45. And I could calculate what those actually are, and then I could say, well, which one has a bigger range? I could try and calculate the mean. I could try and find the mode. Is there a mode? It doesn't look like I've got a mode. Let's have an extra person just walked into room A and someone else just walked into room B. Then my mode for room A would be 15, because the mode is the one that appears the most. Someone else could walk into room B who was also 45. Now I've got 23 and 45 in room B. So actually there's two modes, and that's fine. I can have two modes, I can have three modes, I can have four modes. If there's two people of the same age, and another two people of another age, they're both going to be the mode. If another person walked in that was 23, then the mode would become 23, because then that would be the one that has the most. If several have the most, then technically they're all the mode. So when I had no mode, technically everything was the mode, or there's no mode. So yeah, we can have more than one mode. This is back-to-back stem and leaf. The key is super important, and we use these to find medians, ranges, the mode. What about the mean? The mean, you're still going to have to add up all the numbers and divide by the number of numbers. So it's not necessarily any quicker for finding the mean, but it is quick for finding the range. It's super good for the range. It's good for the mode, and I think it's also quite good for the median as well. So the median is the middle number, the one in the middle. So if we think about the median age of the people in room A, well, how many are in room A? Because someone else just walked in before. So that's 4, 5, 6, 7, 8, 9 now. So we've got 9 people in A. So who's going to be the one in the middle? It's going to be the fifth person. So we've got 1, 2, 3, 4, 5 in the middle, and then 6, 7, 8, 9. So 5's the guy in the middle, right? If you take 9 and divide it by 2, you get 4.5, round it up to 5. So the fifth person. So we want to find the fifth person in room A. And we start counting from the smallest age. So from 11, 12, 15, 15, 24. So the median age of room A is 24. Great. So it's great for finding the median as well. Notice I've written these numbers in order. Yeah. So going from left to right, it's in numerical order. So I haven't written, 11, 15, 12, because that wouldn't be in numerical order. And then that would throw off my calculations for the median. It has to be in order, remember. To find the median, you have to list all of the numbers in order, then find the middle number. So yeah, stem and leaf diagrams must be in numerical order. But don't forget that if you have back-to-back ones that on the left leaves, they kind of go the other way. So they're still in numerical order, but from large to small. Okay, so numerical order. All right, any questions? Not getting any. So just to sort of, I guess, recap, statistics and probability, we're doing chapter 1, representing data. So here's some data, these are ages of people, we've just represented it, right? We used a stem and leaf diagram to represent the data of people's ages in 2 different rooms. And we found that we can, it's quite nice, we can kind of compare, and we can see instantly people in room B are older. We could see pretty much instantly how many people are in each room. Maybe there'll be a lot of people in one room and only a few in the other room. You can see that kind of straight away visually, just from looking at the diagram. The range is super easy to calculate. The median's quite easy to calculate. When it's structured like this, if I just gave you a list of numbers, not in any kind of order, and just said, here's a load of numbers, find me the median age, you'd have to then put them in order and find the median. So this is a useful way of putting those numbers in order, numerical order. And whenever we draw a stem and leaf diagram, we have to include a key, and we can have back-to-back stem and leaf diagrams. Okay. All right. So we've done our first diagram. We've analyzed and interpreted it a little bit. On Wednesday, we'll, I guess, continue to do box and whiskers, histograms, cumulative frequency, and then we'll move towards analysis of those. And hopefully by next Monday, we can start thinking about standard deviation. That's my plan anyway. So don't forget, new Google Classroom, new code, join that please. And I will be posting a couple of questions on there for you guys to have a practice tomorrow. All right. If you've not got any questions, I think we're probably out of time now, so I'll let you guys go for lunch. Have a great day.